So problem solving today, 8G. We've got the rate of change of ambient temperature in a house once the heater is put on is directly proportional to the temperature of the house. And then we've got some information about the initial temperature and so forth. So in this exercise, we're going to be consolidating all the things we've learnt and performing some problem solving. So it says the rate of change of ambient temperature. So ambient temperature of the atmosphere, what we're surrounded by the room. So the rate of change is the slope of temperature, capital T, with regards to time. So I'm going to use capital T for temperature and lowercase t for time. And it is directly proportional to the temperature of the room. So like we often write this, that's the physics one, isn't it? It's directly proportional to T. And so for our purposes, we're going to write as a linear equation, some number multiplied by the temperature. Okay, that's what that means, right? If the rate of change of T is directly proportional to T, then some sort of relationship like this. In a number of these questions, you're going to be given this number to start with, so you don't need to solve it. And then in some of the later on ones, you need to solve this variable as well. All right, let's get straight into it. So what we want to do is we want to solve for T. So I'm going to divide both sides by T. So we'll have 1 on T and then d capital T or dt. And then we will integrate both sides with regards to T. What are we going to have here? Kt plus C. We'll put e to the power of both sides. So we're going to have e will have T, e will have. Alright, we'll follow this operation that we do over here. A is some constant. Alright, so there's the temperature equation, and we've got these two variables here that we need to solve for. We're given enough information to solve. Firstly, we've got the initial temperature is 16 degrees. Okay, so that means T of 0 equals 16. So let's use that piece of information first. Let's plug it in here. We're going to have 16 equals a e to the power of 0. E to the 0 is 1, so therefore a is 16. Alright, so then the new equation that we obtain, temperature is 16 e to the kt. Now, we're also told after 1 hour, so when time is 1, the temperature is 21 degrees. So let's plug that in. The lowercase t is 1. This is the equation that we have. And we can solve for k here. Let's get variable k by itself. Divide both sides by 16. And perform the natural logarithm of both sides. Okay, so then the equation that we have for t, having solved for both of the variables, is 16 e to the power of and we will simplify this a little bit, okay, because up here we've got two things multiplying one another. Remember, order of multiplication doesn't matter, so you could swap them around. But we can write it like this, okay? E to the power of ln, 21 on 16. And so that part simplifies to 21 on 16 to the power of t. Okay? Which is not equal to 21 to the power of t. Why?
Because the t would go.
Yeah, the bed mass. So we think of bed mass, we have to perform any operations in brackets first, and then we have to perform exponents. We can't perform the multiplication before the exponents. So not a legitimate operation, that one. So this is a, this is a simple way to write it. The simplest way to write it. So that's the equation of T, the temperature, with regards to time. All right. Okay, part B, we've got when does the temperature exceed 25 degrees? So now that we have the equation, okay, you can just graph that and G-solve this. You could go, when is the Y value 25? What's the corresponding X value, the time value? All right, but we can also solve this manually. And so this is a good opportunity for us to recap some logarithms here. So what we've got is we've got the temperature, we've got 16 multiplied by 16 at 25, 21 on 16, parity is equal to 25. And we're saying, when is the temperature function equal to 25? And we'll solve this one. Divide both sides by 16. Form the natural logarithm of both sides. So we're going to have T multiplied by 3. And then divide both sides by this variable. Alright, so that's the exact value of time, although that's not particularly useful for us in the context of the problem. So I'll just do a quick solve for that one. Alright, but that's logarithmic operations. We've been doing them since sort of year 11, so we're familiar with that. So we've got ln of 21 divided by 1. Well, the answer is 1. No, I don't think it processed it properly. Because I stuffed up the first one. 25 on 16. Yep, divided by ln 21 on 16. That's right. 1.64 hours. Alright, so you have that heater on for 1.64 hours, and the room will be 25 degrees. Alright, next one says, how about what is the temperature after 45 minutes? So, our unit for time is hours, so we need to consider 45 minutes is 0.75 hours. Okay, so therefore we're going to put that period of time into the equation. Evaluate that one. degrees. All right, so that's the kind of thing we're doing in here. A lot of the development of the equations follows a very similar process. So yeah, let's give it all a bit of a crack.